All right, in this related rate problem, we have a shallow concrete conical reservoir, vertex down, of base radius 50 meters and height 4 meters. We know that the water is flowing at a rate of 50 cubic meters per minute out of this conical reservoir. How fast in centimeters per minute is the water level falling when the water is 3 meters deep? So the first thing we want to do is draw ourselves a picture. I've just drawn myself a cone with the base radius up and the vertex down. The radius here would be 50 meters and the height is 4 meters. Obviously, this is not drawn to scale. And so water is flowing out at a rate of 50 cubic meters or centimeters per minute. Let me make sure I wrote that. No, it's 50 cubic meters per minute, sorry. Now it's minus because as the water flows out of the reservoir, the volume is decreasing or getting smaller, okay? Now, we know then that dV dt is minus 50 meters cubed per minute. What are we looking for? We want to know how fast in centimeters per minute is the water level falling when the water is 3 meters deep. So I've just drawn in my water level like right here, right? So the water level or the depth of the water, so to speak, I'm just going to call H, and the corresponding radius of the top of that will be R. So what we want is dH dt when H is 3 meters. Okay. Because we want to find the rate at which the water level is falling when the water is 3 meters deep. So that's dH dt when H is 3 meters. Now, I will come back here in just a minute and talk about changing it to centimeters per minute, because our information right now is in terms of meters. All right, so this is what we know and what we want. So what we need is an equation relating V, which is the variable we know its rate of change, to H, which is the variable we're looking for its rate of change. And when you're talking about a cone, the volume of a cone is 1/3 pi r squared times H. The problem here is this R. They've neither told me how fast the radius change, nor have they asked me how fast the radius is changing. And if I leave it like this, I'll have to use the product rule on it. So what I would like to do is somehow rewrite R in terms of H. So we have just similar triangles in here. If I pull, say, this triangle and this triangle out here to the side to look at the relationships, so this is 50, this is 4, all of it together. This is R, and this is H. One way we could do this is use the fact that ratios of corresponding sides of similar triangles are equal. So we would have R over 50 is equal to H over 4. So R would be 50H over 4, which is what, 25H over 2, or 12.5H. Okay, so I'm just going to plug 12.5H in for R in my velocity function. So I will have 1/3 pi times 12.5H quantity squared times H, and that's equal to velocity. So velocity would be, let's see, that's pi over 3, 1/3 pi. 12.5 is what did we say, 25 over 2? So when we square that, I'll get 625 over 4. H squared times h is h cubed. So our dv dt, when we take the derivative of both sides with respect to t, we get dv dt is 625 pi over 12. H cubed derivative is 3h squared dh dt. Now I'm going to have to make myself some more room here, so I'm going to erase this part. Okay. Now we wanted to find dh dt. We know dv dt, so we're going to plug in dv dt, and we're going to plug in the current value of h and solve for dh dt. dv dt is negative 50 cubic meters per minute. We have that's equal to 625 pi over 12 times 3 h squared. Remember, h was 3 meters, so that will be 3 meters squared dh dt. So I end up with negative 50 meters cubed per minute times, okay, let's see. If I multiply by the reciprocal of this fraction or that product, I will have times 12 over 625 pi times 27 meters squared. So the meters squared cancel with the meters cubed, and we will be left with meters per minute. And we have 12 times negative 50 over 625 pi times 27. Let me just simplify that. Let's see. 25 goes into 50 2 times. 25 goes into 625 25 times. We could cancel a 3 out of the 12 and 7 and have a 4 and a 9. So it looks like I'm getting negative 8 over 25 times 9, which is 225 pi meters per minute. But they did ask us for this in terms of centimeters per minute. So how many centimeters are in a meter? It's 100. So if I want to change this from meters to minute, meters per minute to centimeters per minute, I'm just going to multiply by a conversion factor that cancels the meters and leaves it in terms of centimeters. And there are 100 centimeters in 1 meter. So that would be negative 800 centimeters over 225 pi per minute, or negative 800 over 225 pi centimeters per minute. Now we could simplify that a bit, I believe. Let's see. Oh goodness. 25 goes into 225, as we saw, 9 times. 25 goes into 800 32 times. So we have negative 32 over 9 pi centimeters per minute. And they did want you to round it to 2 decimal places. So I just plug that into my calculator and let's see what we get. I'm getting about 1.13. Now keep in mind that the negative sign comes from the fact that the water level is falling, but the way they ask their question, they know that, right? So they want to know at what rate is the water level falling. So we would not include the negative sign in there because that negative sign indicates that it's getting smaller. by the way they worded the question, they already know that it's getting smaller. So we would just look at the 1.13 centimeters per minute. Okay, they also want to know how fast is the radius of the water's surface changing at that moment. And I want to start from scratch. We know already a relationship between R and H. And R was 12.5 H. What we want to find the rate at which the radius is changing would be dr dt. And we also know that dH dt was equal to, what was it in exact form? It was negative 32 over 9 pi centimeters per minute. Now I'm using the exact version of the rate of change of H, because if I use the rounded version, that'll just make my rounding error for the rate of change of radius a little bit bigger. So if I want to find dr dt, and I know that R is 12.5 times H, I'm just going to take the derivative of both sides with respect to t, and we'll get dr dt is 12.5 dH dt. So dr dt will be 12.5 times dH dt is negative 32 over 9 pi. Multiply that out. And I'm getting approximately 14.147 centimeters per minute, and rounded to two decimal places would be 14.15 centimeters per minute. Now notice I once again didn't include the negative sign there. That's just an indication that the radius is getting smaller as the water level drops. But the way they asked me the question was, how fast is the radius changing? So they didn't ask me, is it getting bigger or smaller? The rate at which it's changing is going to be 14.15 centimeters per minute.